All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 3, SLT number 21, an introduction into rational functions. Now, before we get into rational functions, we want to talk about two different types of functions that we had done in the past, which had both horizontal asymptotes and vertical asymptotes, because rational functions are going to have both. If a function like this has just a horizontal asymptote, then this is an exponential function. Because it's increasing very quickly like this. Its domain can be anything, so the domain is all real numbers because x can be any number and it always has an answer. This is going up infinitely to the right. It is going up more than it's going right, but it is going to keep going right infinitely, so every domain has a possible answer. Now the range has to be everything that's above 0 because this function never goes below the asymptote. That's literally what the dotted line represents. It's that height that it's never going to reach. It's never going to be below that. And this one is increasing because you always read a function from left to right, and this one's going up. Its asymptote is at y equals 0 because if you think about that dotted line is hitting the y-axis here at 0. Easy way of thinking about it. Y equals always goes horizontally and x equals always goes vertically. Now the equation to this, we could always say it's y-intercept times the rate to the power of x. So the next one is a height of 3, so it's 1 times 3 to the power of x. Alright, for this one over here, then we have a logarithmic function. And the reason I know that is because it has a vertical asymptote. This time the domain can be anything that's greater than 0 because this function never goes further left than that asymptote. But the range this time can be anything. So these are inverses of each other, so therefore it should not shock you that the domains and ranges have switched because they're basically the exact same equation. This one is also increasing. It has an asymptote of x equals 0 because it has a vertical line. And the equation for this, where is it 1 away? So then you find the next one. So this is log base 4 of x. Pen, not writing. There we go. Sorry for that lag. So log base 4 of x. All right. Next question. So Chile. So we're getting into, this is a word problem that has to do with rational functions. How much would each person have to spend if two people were splitting the cost of a $360 present? Now, if two people were doing it, it'd be $180 per person. If three people, that'd be $120 going in. So 5 people were going into 360. I should have my calculator on me. So what is that? 5 times 6. 5 times 7 is 35. $72. 10 would be $36, and 100 people would be $3.60. Now, how did I do that? All I did was take my $360 and divide it by how many people are splitting the cost equally. Because that's really what you're doing when you're dividing. You're splitting something equally. So this rational function, what did we do each time we divide out the cost? That was divide, so what did the cost depend on? The cost depends upon how many people are splitting it. So our function is to represent, so we're trying to represent the cost in terms of per person, and that function would be such. So f of x is equal to, so $360 being split by x amount of people. So anytime you have a variable in the denominator of a fraction, because you remember rational numbers are any numbers that can be expressed as a fraction. So anytime you have a variable in the denominator, then you have a rational function. If the cost per person is $12, how many people must have shared the cost? Well, if the cost was $12, that's the f of x, is equal to 360 over x, then you can just simply solve this. Now you can solve it a couple of different ways. You can cross multiply, that give you 12x equals 360. Divide both sides by 12, and you have your answer of 30. So 30 people must have shared the cost if the cost is $12. Now, what would this look like on a graph? Now, I know we came up with some of the numbers, and I'll come up with more of them. So if it was $360 and you shared amongst 5 people, 10 people, $360 was $36. That one's easy. So this one was $72. That was there. $360 divided by 20, 5, 10, 15, 20. 5, 15, 18, if I'm not mistaken. 360 divided by 60 would be 6. and so forth. Now, there's a lot more points that you could include on this graph, but what you can see is the general trend of what's happening. So this is what a rational function looks like. Now, it just so happens in this question that the negatives don't make sense in the context of the question, but typically when you see in the next video, rational functions are going to have one on this side and one over here on this side. But you can't split a cost of a present equally amongst negative amount of people. That's not possible. Nor can each person be giving you less than, a penny. So that you have to give, everybody has to be sharing something. I mean, they can't be giving you nothing, because that's the reason why it's one of the asymptotes, is because if everybody gives nothing, then you're never going to have enough money for that present. I mean, no matter how many people give you nothing, it doesn't really matter. So I kind of just answered these two questions down here. So the domain in this case will be anything that's greater than 0. The range is also anything greater than 0. So they have to give you something, and there has to be more than 0 people, and there also happens to be more than $0 per person. Now, this is a discrete question. I do want to point this out, that you can't have a half a person give you money. So technically, I really wouldn't have connected this dotted points. I just wanted to show you what a rational function looked like, although technically that's not the way you would graph it to this question itself. So this has an x equals 0 and a y equals 0 asymptote. So for the reasons I had mentioned before about these two questions down here. And it never intercepts anything. All right, so here's our parent function for a rational function. Remember I said before, rational number is any number expressed as a fraction. A rational function is anything where it has a variable in the denominator. So a ratio is just a fraction of two polynomials. So you've got p of x divided by q of x, where q of x cannot be 0. And the reason why it can't be 0 is because you can never divide any number divided by 0. It just does not make sense. You can't split something into equal groups of nothing. It doesn't make sense in the context of the question. The domain for this case would be S would be a set of all real numbers in which x cannot be 0. Now, you can't just say x can be all real numbers, because it can be anything. It can be a positive number, it can be a negative number. The only thing that x can't be is 0 because of this vertical asymptote. It'll never have, 0 will never have any answer. No matter if you go up or down, it has no answers. Range, same thing. So y can be a set of all real numbers in which y cannot be 0 either. Because once again, that has that x equals 0, that y equals 0 asymptote, that horizontal asymptote, which tells you that no matter if you go further left or right, it doesn't matter which piece that you use, you're never going to hit that 0 asymptote. So then we talk about end behavior. Since we don't know where it's going to end, it never really does end. This piece always goes infinitely to the left and up. This piece goes down and to the right infinitely as well. So what we say is s goes towards positive infinity. That means to the right. So x is this axis, okay, and this is your f of x axis, which is your y axis, technically. F of x is the same thing as y. So as we go to the right, the closer the height is approaching 0. The further we go to the left, now I could have switched these around, it wouldn't really make any difference. The further I go to the left, this piece right here, the closer and closer and closer it gets to a 0. We use an arrow to represent approaching, because it's never going to actually hit 0, because as we know, for infinity, it's going to go up and to the left, but it's never going to hit 0. This is an odd function. This is very important because odd and even functions describe to you how it is a reflection to itself. So there's two pieces to this rational function, and each piece is an odd function because it reflects over the origin. So this point on the other side, an equal and opposite point on the other side of the origin. This point right here, I could say equal and opposite side of the origin. Same thing for this point, equal and opposite side of the function on the opposite side of the origin, so therefore it's an odd function. That's the reason I can tell. That was that last answer. And I'm going to stop it right there. Please give it a like to help you learn something about just general idea of rational functions. And please look forward to the next couple of videos, which will be coming out shortly, which go into more detail about how to graph rational functions. All right. Thanks again for watching. Have a great day.